Alright, so this one may or may not be long, so I'm going to close this for now because I want to move some files around. So I'm going to go back into my Linux drive, then go back into my C project, and then I'm going to create a folder called source. I'm going to take my main, I'm going to put it in there. So now I'm going to try and run my project again. I have to do, I'm going to run my CMake, and my, an error. But I knew that was going to happen. So here's what we have to do. You can see how it comes in, and it goes through here, blah, 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 assigns the project, but this executable is no longer inside of the root CMake folder, right? So I called CMake from build, and I told it to go back one directory. It looks for the CMake lists, which goes in here, comes in and executes all these statements, but here is where it gets to a problem because my main doesn't exist anymore. My main doesn't exist in my C project, it exists in my C project /source. Right, so if I go back one directory, oh, that's terrible. I went back too far. Line search, cd, source. My main exists here inside of source. So luckily we can work with this, and the way you do that is by creating a CMake lists file. Well, I'm in the complete wrong folder again, inside of the source folder here. So let's do that. Let's make CMake lists.txt. So now, as usual, I'm going to tell the people stuff. Whatever, I'm going to tell the people. What do I usually say? Print message to people. That's what I say. Message, status message, inside of sources CMake lists. And then I'm going to do the same thing. I'm going to say finished. Alright, now I'm going to run my CMake from my build, CMake. But you'll see like it never gets into my sources directory, right? I go here, but it doesn't know that these exist. And the way we can fix that is by adding a line like this that says add subdirectory source. Add subdirectory source. Am I in the right source? Let me open another one for good syntax. Oops, wrong folder. Alright, let me look at this. How did I do that here? Oh, I don't want that. I want this root folder. Yeah, that's right. Add subdirectory is right. Alright, let me close all these and then go back and open this again. Add subdirectory source. Let me see if I can remove the build and then make it again. I'm just dumb and not paying attention to the output. So it did make it inside the source's CMake. The error is coming from the main that doesn't exist. So let me open up the CMake that we're working with inside of my C project source open. Okay, so we did make it inside of here. I'm just not paying attention. Set sources main.c. So one of the problems with this is that if I do this and I come down here and I say, if I said this, right, this is the variable thing we've been working with earlier. no source is given to target. That's because we've set this variable and it's only in the scope of this folder. So there's a command called parent scope that lets this exist throughout the project. What? I wonder if I have to do that. I do. Okay. There are two things here. So one of them we will go through at the same time. Okay. So first let's do this. Let's understand why this doesn't work. No source is given. The reason is because it's only available in the scope that it's defined in. So this is the root scope. It can see any file, but not folder. It doesn't know the folders exist. So inside of here, this can see all the files, but it doesn't know any other folders exist. So where my source folder doesn't know that my project folder exists. So great. Now, one thing is we can handle this a little bit better. And the way we can do that is like this. There is something called print CMake source directory. And this is the, oh, it's not print, it's message. This is the root directory that CMake is operating from. Is CMake source dir. I think this is a built-in variable to CMake. I didn't name this. CMake source directory is home, Nick Munson 22, my C project. That is the root CMake location, right? This is my C project exists. Let me go back one. My C project exists here. So that's the CMake source directory. Let me go back into the build folder. Now I can set a variable that I can set below. Set up source directory. I can set this up like this. Set source directory. And because I know the file structure, I know that this is where it is. I know that my sources are in CMake/source. So let me go back and I go cd src for source. And I line search and then I print the working directory. I know that my sources are here. So what I'm doing is making a variable called set source directory, or sorry, source directory to hold them. Source directory is, and then I'm going to print it out so that I can see if I've assigned it correctly. Source directory. So this is just an easier way to manage all this file structure. So you have variables for everything. So source directory is here. My source directory, sorry, the CMake source directory, this is where the root CMake is in my C project. The source directory is in my C project/source. Now instead of this, I can actually go source directory. Now this is the variable that I've created. I'm setting that equal to sources and I'm giving it parent scope. I need to do this because it's a file path, so you can't, like, if I put a space there, they're separate variables. Source directory /main.c. Great. One thing that's interesting is if I message and I do a status and I print sources, watch what happens. Watch what happens. Sources in source are you see how this is blank? Well, one, because I botched this variable name. Don't listen to me yet. It will be blank though. will have no information. You see how this is empty? The reason is because of this parent scope. So this makes sources only available to the parent scope, which in this case would be, if I was in this directory, my parent is here. So what is not convention, but usually people will do this so that you can have a local variable and a variable for the parent scope. So this is my sources in this. You see how sources in the sources CMake. You can see how I've assigned that to this local variable, and then I set that local variable into a sources variable and give it parent scope. What have I done wrong? Do I need to do like this maybe? What the fook? How did I handle this in my other project? What am I doing wrong here? 1 second. My test Python environment, C source, CMake list, open. No, I did it exactly this way. Oh, I'm so dumb. Because this is a variable, I have to do this now. Duh. Once you assign a variable in a CMake list, you have to refer to it in this syntax. That should clear that up. Okay, so now what we're looking at, sources. I'm inside my sources CMake. My sources are this. Yay! Okay. Now I want to go back here and I want to say add sources to the project. And what I want to do is print this. Sources inside root CMake. Wow, I can't type R. And now I'm having my srcs variable, my sources variable. And watch what this will print out. Okay, so I'm inside my sources. Here are my local sources. I'm finished. Now my sources inside the root are here. Great. So what I should be able to do now is make and then / my executable and whatever we were working with before, it all prints out. That's great. So what I want to show now is, let me go to my Linux files, my C project, source, main. What I'm going to do now is close all of this, because what I want to show is how do we make functions that are not existing inside of this, right? If we wanted to put every function in this, it would be a pain in the butt. So what I'm going to do is we're going to take this and move it to a different file location, and we're going to show how to do that. So in C and C++, you actually need something called a header file. So I'm going to call this helper functions.h. Great. And the way user defined includes, and the way you notify this file that this other file exists is you say helper functions.h. Okay, so now inside of this there's a weird thing you have to do to avoid redefining things. So if I have int x equals 0, I actually can't say int x equals 0 again. It'll give an error, and I'll demonstrate that right now. So this is a redefinition error. So this applies to variables and functions. So what I'm about to show you is called header guard. So if not defined, and then you have a variable here which is a macro, helper functions _h. I'm going to define this helper functions _h, and I'm going to end it. This is just syntax, end definition, end helper _h. _h. This is not syntax, just convention. Like this naming is not syntax. So what I'm saying is if this is not defined already, I'm going to define it, and I'm going to define it like this. I'm going to put a function we'll call void because it won't return anything. Return modify, maybe we'll call it modify array. So great. I have this include. That means when I execute main, anything that is used here is available to my main. So let me make and do this. Great. But you'll notice like I could write code here, but it's kind of awkward with this macro definition, and if I haven't defined this, and how do I know what's going on? So typically we define another source file where the code sits. So header files tell you what functions exist, and source files contain the code. So they have to have the same name, like this. So we have, oh, I didn't do it right. Let me close that and then rename it. So in my source, rename header functions, open with text. So now I have my CMake list in my source, my CMake list in my root, my main, and then a header function. So I can do this, like let me do this, and this is how you define your functions in C. Uh-oh, that's Yang calling. Let me tell her 1 second because I'm finishing my video. Okay, so this is where the code would sit, and how this works, I'm going to say printf inside my array, modify array. And then I'm going to say finished. Now the way C works is interesting. So if I run this, my main doesn't even know that this function exists, right? Like if I call this, we'll see what happens. If I like, here, let me call this and we'll just go through this. Okay, undefined reference to modify array. Well, what is wrong here? So it found our function, and if I do this, right, we'll see what error this produces. So effectively, our main can't even see this function. Even if I use the include the way I did before, it can't find it. And the reason is because we actually need to include it in our sources so that we know to add it to the executable. So what we do is we hit enter a bunch of times, and then we do this source directory / helper functions.c. And then it's convention that you set this over here. I don't know why. So let's do a message set local sources, set sources for root. And then I'm going to do that so it looks better. Make. Uh-oh, now I have a syntax error, but this is good because now if we look at this, it's actually gone inside the function inside of my source file. So now if I do this and this, let's see. Uh-oh. So this is kind of the way C works. You have to have support in the file you're using, right? Like just because I define standard IO here doesn't mean it exists here. So I'm going to take their warning and their error and use an include here. Include the standard IO. Make. And then it runs. So you can actually see that it's traversed its way through these functions, right? So you have to have a helper, we have to have an H file or a header file definition, and then you have to have the same function name with its actual definition. Let me add some new lines here. Inside of the source file. And then you have to include the header file. And essentially when you do this, it goes to here, it says, okay, that's great. I have a definition for this. And then you traverse your way into that. Great, so you can see how the flow works. Amazing. So as the name suggests, what we're gonna do is we're just gonna create another array. It's of size 10 maybe. And we're gonna have my array, and we're going to give it the array size to initialize. Great. We're going to let's just pass it in and see what we can do. Okay, as we did before, we're just going to do this, and we're going to run. Let me do a CMake actually. Okay. So, we did it without error, but what we need to do is, let me try this. So what you have to do here is, there we go. If you pass the wrong argument type, if you have a void function, it essentially nullifies all arguments, which is what this behavior means. It means that this input is void. It doesn't matter if you give it an input, it won't take one, and it won't tell you it's not there. We actually need to do this. We need to have the inputs defined and the outputs. So we're defining an input array here as our input and a no output type. Void means no output type, so there's no output coming from this function. Then we've done it. So what I'm going to do first is I also need the size of this array, so I'm going to create a variable here called intSize. I'm going to take it and I have to place it here as well. And then I need to pass it from main. Great. Let's compile and run this. Make sure we're going at the rate. Good. Okay, so now what I'm going to do is for int x equals 0 while x is less than size, x plus plus. So what I'm going to do is array at x equals x times 10 maybe, just some stuff. Then we're going to take this same loop structure and going to paste it here. Obviously we now have to change these. And now we're going to printf my array at integer. Now let's get rid of this. Also an integer. New line end x my array at x. Done. Okay, let's see what we get out of this. Alright, so you can see we went to main, we went inside the modify array, we finished it, we added, we multiplied each index, x times 0, x times 10, and then now we're back inside of main and we print it, then we finish main. So this is kind of a setup to how you have to build your CMake list and how you can set your sources up for your local, set those into a variable for the root, and then you add all of those sources to the executable. So that's what I wanted to cover in this video, and then in the next one we'll talk about how to import things and set up custom CMake files to find all of your supporting modules.